Hello dear students, in this video we intend to discuss the Fischer and Haworth projection of D-glucose. The molecular formula for D-glucose or the glucose is C6H12O6 and we all know glucose is aldose sugar having aldehyde group. So to draw the structure, what we need to do is, firstly we will draw a chain of 6 carbon, like this chain is open chain of 6 carbon. We know glucose is aldose sugar, so at the first carbon we will draw aldehyde group. Then many times you have confusion like at what carbon OH should be at left, at what carbon OH should be at right. So there is no confusion. You need to find the third carbon. This is 1, 2 and this is the third carbon. At the third carbon, what you need to do is you need to keep hydrogen at right and OH at left. Rest all of the carbon will have OH at right. OH, 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 OH. Now we can satisfy with the hydrogen. This carbon having 3 bonds already formed. So the fourth bond will be formed with hydrogen. And then all the hydrogens can be kept like this. This carbon you can see only 2 bonds are formed, so this will have obviously 2 hydrogens. So this is open chain structure. Now you can see the closed chain structure also. What you need to see is this oxygen will have partial negative charge because of the breaking of the bond. This carbon will have partial positive charge. So now to close the chain, you need to find the fifth carbon. Where is the fifth carbon? 1, 2, 3, 4, 5. This is the fifth carbon. So at the fifth carbon, you see the OH group. This OH group is supposed to give this H plus. This H plus will get combined with this O minus, and this oxygen will, the oxygen of fifth carbon will form bond with the oxygen of the first carbon. See how? Now you see I have highlighted the first and the fifth carbon. At the first carbon, this double bond should be broken to form a single bond. This O will become OH. This hydrogen will remain as it is. Now what happens at the fifth carbon? This H is not here. This becomes O and this oxygen will form bond with the first carbon. So you can draw it like this. This oxygen I can write over here just for the symmetrical structure. And this is the CH2OH. No changes required at the sixth carbon and no changes anywhere, like third carbon having hydrogen at right and OH over here. Rest you can copy as it is. OH, H, H, OH. See, this hydrogen of the first carbon, I repeat, the hydrogen of the first carbon is at left. You will call it alpha D glucose. What will we do for the beta D glucose? The entire structure will remain same. The difference is the bonds of the first carbon will be interchanged. Like this OH will be over here at the left and the H will be at the right to form beta D glucose. See how? So at the first carbon, hydrogen is at right and OH, just we have reversed the bond. So you will get beta D glucose. You can see there is no other changes, like only the first carbon, like this carbon will change its bond, and the third carbon, keep remember the third carbon will always have hydrogen at the right. Same goes with the fructose also. When you will see the structure of fructose, the major confusion becomes like where to OH, where to H. So you need to keep remember at the third carbon H should be at right, rest all OH at right. Okay, with this structure we can form Haworth projection, that is a ring structure, that is also called Paranose ring. All right, see how does it happen? You need to see this, like this is a closed ring. I am counting the number of carbon: 1, 2, 3, 4, 5 carbon, and this ring contains 1 oxygen also. That means this should be a 6-membered ring containing 1 oxygen. So what will we do? We will draw firstly a hexagonal a 6-membered ring having 1 oxygen in the structure. So here we go. We have drawn paranose ring, this oxygen, and having 5 carbons. 1, 2, 3, 4, 5. Now see the numbering. Start numbering from here. This is the first carbon, this one. Second, third, fourth, and fifth. And what about the sixth carbon? About this. Just this is the sixth carbon, CH2OH. That you need to keep remember. Now the biggest confusion is where the OH needs to be drawn at top, where the H needs to be drawn at top. So you need to keep remember the groups that are at right. I repeat, the groups that are at right should be at bottom. So what groups are at right? Like see the first carbon. At the first carbon, OH is at right, H is at left. All right. Second carbon, like this. What is at right? Again OH and H. Third carbon, H is at right. So we will be drawing H, OH. About the fourth carbon, where is the fourth carbon? This. OH at right. So OH will be drawn at bottom and H. And at the fifth carbon, CH2OH already drawn. And you see the very, at the fifth carbon, this CH2 OH is already drawn. And 1 minute please. This is the fifth carbon connecting with the oxygen like this. Yeah, sorry, one hydrogen needs to be here now. Like this is carbon having 1, 2, 3, fourth one with the hydrogen. So one hydrogen over here because it is at left, so it will be drawn. In the fifth carbon you need to keep remember the CH2OH will be remaining over here as a sixth carbon. That you need to keep remember. Rest all done. So the confusion was in between H and OH. So it is resolved by the at the groups at right should be at at the bottom. So this is like alpha D glucose. If you need to draw the beta D glucose, so there should be no change required in the beta D glucose except the first carbon. This is the first carbon. I am highlighting with the red one. This is the first carbon. Just to reverse these bonds, these groups are actually OH at top, H at bottom. So you will get the beta D glucose. All right. So the key points to draw the structure is about the third carbon. Third carbon, at the third carbon, the hydrogen should be at right. And next thing is the groups placed at right should be at bottom, and the group placed at left should be at top while drawing the Haworth projection. I hope I made it clear. Thank you.